Thank you, Stuart.
Thank you. My name's Stuart Shaw. I'm from Oracle, and more specifically, I'm from Oracle Utilities. And I'm here today to help share some of the experiences and probably the things that need to be considered with a smart meter, smart grid rollout. Oops.
And the prize for the fastest presentation goes to...
Yeah, that was pretty good. Yeah. With the smart grid, and in fact moving into the smart city, digital is going to change everything. It's really changing expectations, expectations of the workforce, expectations of the customer, business models, speed to market, how you actually deliver things. So all of these things will change as part of rolling out the smart grid, moving into the smart city. So expect change. Utilities of today generally tend to be reactive to what's going on in the network, what's going on with their customers. If they have an outage, they go and address it. Customers come in with bill complaints, they address it. Going forward, and particularly using the new technology, utilities are now moving to become more proactive and prescriptive. That means they're going to change how they do their work processes, so optimising their workflow. Their services are going to need to change, and the expectation from the customer and the companies will be exceptional service. And there's also prevention of costs, and driving down the cost with the new technology, and then also mitigating operational risks. So instead of having the outage, try and predict where the outage is, trying to predict where the fault is, where the meter is going to fail, where the transformer is going to fail. So these are all of the things today which utilities moving into the future really want to achieve, and they need to look at doing this. The grid, looking at how the grid works, particularly with smart meters, and this also applies when you're pulling in renewable energy, wind, solar. Currently the grid goes up to the pole into the house, but when you start to look at, oops, something's gone wrong with this presentation. When you start to look at how that then goes forward with where the grid is, as soon as you start putting in sensors and DERs into the household, the grid changes. You put in solar panels and you're having energy coming out into the household, out into the buildings, and the energy can also go back in at low use times in the house. So you've got energy going two ways. You've got sensors within the house that need to be managed, sensors in how you actually operate the house itself, that changes, and if you also add in electric vehicles, that's going to change how demand works within across the time frame, also day and night. So all of these things need to be considered. Currently, systems and SCADA and the DMS systems today work up into the pole outside the house. In the future, you're going to need to look at working into the house because you've got all of the extra sensors in there to be managed. I'm not quite sure what's gone wrong with my presentation, so I'll try and... Okay, I'll continue on and use this. The other thing that you're going to need to consider is projected growth of smart devices, and that might be devices, might be smart meters, might be sensors, etc. Is going to go from 500 million in 2013 to 1.5 billion in 2020. That's the projection. I suspect that that's actually going to be more. The other thing that needs to be considered with this is the data that comes from those devices. And one of the things that we're seeing around the world is with the smart meters have multiple channels in which they can provide data. So when we first started seeing smart meters, they were using between 2 and 4 channels and then moving up to 8. We're now seeing countries looking at using tens of channels, and even one country that's talking about using 100 channels. That's a multiplication factor on the amount of data that you're going to have to address. And it's also, the value of that is then you have all of this additional data in which you can use to manage not only your network, but also manage your customer. You understand more about your customer, you understand more about how your network works. So taking this data and managing that data and doing analytics on that data is something that needs to be considered and probably considered very early on. What do you want to get out of the data? How do you want to manage the network? How do you want to manage the utility? How do you want to manage the customer? And what's the customer going to expect from you? Okay, this somehow the slides have ended up coming out of order, but this is where we're talking about the sensors within the house. I'll move past this one. The other thing is asset management. I think the point's been made here by a couple of people. There's a lot of information that you can gather from around the world. Many countries around the world are doing smart grid. There are different stages of the smart grid cycle. And so there's a lot of information that can be pulled in. But for India needs to look at that in the context of India. The infrastructure in India and the logistics in India are different to other countries. So that needs to be taken into context. Ageing infrastructure, so the assets. I know through the APDRP and IPDS programs, looking at rolling out and upgrading the infrastructure, that is going to need to continue. Aggregating the AMI data, and that AMI data, and that's that, lots of data that you're going to get. You need to look at that and how are you going to use it? What do you want to use the data for? How do you want to manage your network? Also, that can help you, and I think the point's been made before, is managing at-risk or identifying at-risk components in the network. Transformers can fail for lots of different reasons. Age is one of them. Overloading tends to be another really good one. If you can identify that a transformer is being overloaded, reduce the load on that transformer, you can actually get more life out of the transformer, hence reduce cost of the network. Those sorts of things. And then, as I mentioned earlier, electric vehicles. That is going to change the demand on the network. You're going to have peak demands during the day, but your demand at night probably is not going to drop to what it does today. It's probably very quiet overnight. If you end up putting lots and lots of electric vehicles in and other electric appliances that get charged overnight, the demand is still going to be relative, might be as high during the day, but it's going to be higher. That needs to be factored in. And I'm missing one slide, this one. The other thing, and this is particularly in managing the whole smart grid, is utilities are going to have to look at very specifically is how they're going to manage it. The operations management is going to need to be real time. It's going to need to have a single model. It's going to need to deal with the managing the DERs. You're going to need an OMS and a DMS that manages to the edge of the grid, or the new edge of the grid. It's going to have to interact with data from SCADA, with all of the metadata that comes in, with data from workforce, with the mobile workforce, with the customer data, with GIS data. All of that is going to need to be pulled together, and it's going to be need to be managed real time to actually get the benefits and to improve the network and get the savings and the benefits out of the smart grid that you're looking for. So these are things that we've seen from around the world, and we wanted to share with you as things that need to be considered. The smart grid to be very, very successful, it needs to be planned. And you've also got the smart city program coming. And the smart grid will end up being part of the smart city. All of this needs to be planned as to how the smart grid's going to operate, what you expect out of it, or how you expect that to work within a smart city, and then how you actually take it outside the urban areas into the rural areas. So success of the smart grid, and I agree with all of the other presenters and what they've been saying, planning is going to be key, looking at technology that can deal with the change that's coming in the network, and also dealing with the changes in expectations. Thank you.
Thank you.